So the next type of differential equation is of second order and first degree. Generally, we represent the differential equation as f of d y equal to r, and this f of d is represented as a d square plus bd plus c y equal to r. Depending on the value of r, we differentiate this differential equation into two types. First one, it is a homogeneous differential equation of second order. These equations are called as a homogeneous differential equation if the value of r is equal to 0. Similarly, the second type is called as a non-homogeneous differential equation of second order, and if the value of r is not equal to 0, then such kind of equation are called as a non-homogeneous differential equation of second order. So let us consider the first case, that is a homogeneous differential equation of second order. In this we are saying that the value of r is equal to 0. So the solution which we obtain, or the solution of such kind of differential equation, is same as that of a complementary function which we obtain by finding the roots of the given equation. So let's consider an example. Considering an example, we will just look at the types of roots which we obtain from the function, that is f of d. So basically we are considering a second order differential equation, so we will obtain two roots, that is m1 and m2. So if the roots are real and distinct, then we obtain the complementary function as c1 e to the power m1x plus c2 e to the power m2x. Similarly, if we obtain the roots having real values but are same, that is we are saying that m1 is equal to m2, then the complementary function which we obtain is given as c1 plus c2x e to the power mx. I have considered this m1 is equal to m2 equal to m. Similarly, there is a third type of root which we obtain from the differential equation, that is if the roots are complex. If the roots are complex, that is in the form of a plus or minus ib, then the complementary function or the solution of the differential equation will be e to the power alpha x, or or alpha x, rather than writing alpha x I will write ax into c1 sine bx plus c2 cos bx. So depending on the type of roots which we have obtained, we will get different type of solution. If the roots are real and distinct, then we will obtain this kind of solution. If the roots are real but both the roots are equal, then the solution will be something like this. And if the roots are complex, then we will find the solution as something like this. So let us consider an example. We are provided with y double dash minus 5y dash plus 6 equal to 0. Basically, this type of questions do not appear in NET examination. They mostly ask this question in your GATE examination or your SET examination, because these questions are not that complex. They can be solved within 1 or 2 minutes, hardly 1 or 2 minutes. So this type of question they do not ask in your NET examination. Only they will ask you for GATE and for gate examination also they will ask you for 1 mark, and for set examination they will ask you for 2 marks. So let's consider this example: y double dash minus 5y dash plus 6 equal to 0. So this equation appears something like this, or we can represent this equation as something: d square minus 5d plus 6y equal to 0. So we can find the roots as d minus 3 into d minus 2 equal to 0. So d will be equal to 3 comma 2. So the roots are real and distinct. So the complementary function is itself the solution of the given differential equation will be given as c1 e to the power 2x plus c2 e to the power 3x. Let's consider another example: y double dash plus omega square y equal to 0. So we can represent the above equation as d square plus omega square y equal to 0. So d is equal to plus minus I omega will be the roots of this equation. So we can say that the corresponding roots which we have obtained are complex, and we know what will be the complementary functions if we obtain a complex root. So the solution or the complementary function for a complex root will be given as e to the power, over here alpha is equal to 0, so 0x I am writing over here, into c1 sine of omega x plus c2 cos of omega x will be the solution, and e to the power 0x will be equal to 1. So this will be the final solution of our given differential equation. So take down few examples, try to solve these examples. Example is y double dash plus 4y dash plus 5y equal to 0. So the solution for this equation is e to the power minus 2x c1 sin x plus c2 cos x. Similarly, take another example, that is d2 plus d equal to 0. The solution for this equation is y equal to c1 plus c2 e to the power minus x. Take one more example, d square plus 8d plus 16 equal to 0, and the solution for this equation is c1 plus c2x e to the power minus 4x. So just try to find these differential equations and verify your answer. So the next type of differential equation is a particular integral type. As we have discussed about complementary function type, that is a homogeneous differential equation, we have considered f of d y equal to r. If value of r is equal to 0, then we call it as a homogeneous differential equation, but the solution which we obtain is equal to the complementary function of the differential equation. Similarly, if r is not equal to 0, then we used to call it as a non-homogeneous differential equation, or the solution of the differential equation is equal to the particular integral type solution. So what is this particular integral type? So particular integral type is given by 1 upon f of d into r. So how to solve this type of differential equation, we will check if the value of r is equal to e to the power plus or minus x, we are provided with the differential function f of dy equal to e to the power plus or minus ax. We know that if the value of r is not equal to 0, then the solution of differential equation is a particular integral type of differential equation, or the solution is a particular integral solution. And we know the particular integral solution is given by ypi equal to 1 upon f of d into r. Over here r is equal to e to the power plus or minus ax. So this differential equation, or such kind of differential equation whose value is e to the power plus or minus ax, then we can determine the solution in different steps. First one, put d equal to plus or minus a. If we have provided with the function e to the power plus ax, then substitute the value of a in the given differential equation, or put d equal to plus a. If we are provided with e to the power minus ax, then substitute the value of a as equal to substitute the value of d equal to minus a, and check whether the denominator is equal to 0 or not. So if denominator is not equal to 0, then it is fine. Just simply substitute the corresponding value and you will get the solution, or after substitution, whatever the value of this particular integral solution is itself the solution of our differential equation. If in case the denominator is equal to 0, if I'm writing denominator is equal to 0, then simply differentiate the denominator. Then differentiate the denominator and multiply numerator by x. After doing so, whatever will be the value, or I can say repeat the step, that is substitute the value of d equal to plus or minus a, check whether the denominator is equal to 0 or not. If it is not 0, then that will be the solution. If it is equal to 0, then once again differentiate the denominator and once again multiply it with x. Then you will get the corresponding solution. This step is repeated unless and until the denominator is not equal to 0. So let's check one example, so it will be clear to you how to solve such kind of differential equation. So let's consider an example. D square minus 4d plus 4y equal to e to the power 2x. So over here the value of a is equal to 2. Now we are provided with f of d equal to d square minus 4d plus 4. So find out the particular integral solution, which is given by 1 upon f of d. I am directly substituting the value f of d plus 4 into e to the power 2x. So now we know that a is equal to 2. Simply substitute the value of 2 over here. So we have 1 upon 2 square is equal to 4 minus 4 into 2 is equal to 8 plus 4. So now the total sum at the denominator is equal to 0. So over here I can say that the denominator is equal to 0. So I need to differentiate the denominator. So after differentiation, what I get? 2d minus 4 into e to the power 2x. Now as I've told you, after differentiation of denominator, I need to multiply with x on numerator. Then once again substitute the value of d equal to plus 2. So what I get? X upon 2 into 2 is equal to 4, 4 minus 4, once again it is equal to 0. So once again I need to differentiate the denominator. After differentiation, what I get? 2. And once again I need to multiply with the x on numerator. So it will be equal to x square into e to the power 2x. So this will be the solution, as I cannot substitute the value of a in the f of d, or there is no term d in the equation. So this will be the solution of our differential equation. In this way we can determine the differential equation if the value of r is equal to e to the power plus or minus ax. Let us consider another example. So another example is d square minus 3d plus 2y equal to e to the power 3x. Now over here value of a is equal to 3. So the particular integral solution is equal to 1 upon d square minus 3d plus 2 into e to the power 3x. Now substitute the value of d equal to plus 3, then just check whether we are getting denominator equal to 0 or not. So after substituting the value of d equal to 3, then we get d square. So value of a is equal to 3, so d square will be equal to 9 minus 9 plus 2 into e to the power 3x. So if I sum up the denominator quantity, then it is not equal to 0. So I can say the total sum of the denominator is not equal to 0, then the solution is e to the power 3x upon 2. So this is the solution of our differential equation, or of our given differential equation. So hopefully you have understood how to determine the solution of differential equation if the value of r is equal to e to the power plus or minus ax. So just try this examples. D square plus 5d plus 6y equal to e to the power minus 2x. The solution of this differential equation is x e to the power minus 2x. So just try one more example. D square minus 5d plus 6y equal to e to the power 5x. So the solution of this differential equation is 1 by 6 e to the power 5x. So just cross verify these solutions. If you are getting this, it's very nice. If you are not getting, just then try once again. So that's it for today. Thank you.